WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the ECO Learner Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch ECO Learner Support for WAEC and NECO candidates on this station. Learners can also connect with ECO Learner Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. ECO Learner Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Hello learners, you are welcome to ECO Learners Support for WAEC and NECO candidates. Today we are taking physics, and the topic before us is measurement and dimension analysis. Follow me as we go.
ECO Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
We are considering measurement and dimension analysis. When you hear the word measurement and dimension analysis, what comes to your mind? Don't worry, this is what we'll be considering. We'll be looking at the meaning of measurement, the professional and practical application of measurement, measured quantities. What are those quantities that we measure? That is the fundamental and derived quantities. Also, we'll look at the measurement of length, mass, weight, and time. We'll also now look at dimension analysis of those quantities. Now, our objective is this, that at the end of this lesson, you should be able to describe the term measurement. Not only that, you should be able to enumerate different practical and professional application of measurement, which means that you should be able to tell us where you can apply measurement. Also, you should be able to differentiate between fundamental and derived quantities. In conclusion, you should be able to compare and contrast mass and weight. Let's go. Now look at it. What is measurement? When you hear the measurement, what comes to your mind? What comes to your mind should be quantifying. Let's take it from our kitchen. Mommy say go and cook. Go and cook 2 cups of rice. You have to measure. So measurement is a means or a process of quantifying the amount of substance. In physics, when measurements are done, they are recorded in terms of 2 parameters. And these parameters gives the quantity and the quality. So the quantity is denoted using a number, while the quality is denoted using symbols. We call them units. Let's take for instance now. We talk about, I just mentioned measurement, and then quality and quantity. Look at this now. This is 10. This is 10. The quantity here is 10. Both of them are 10. Let's say both numbers are 10. 10 here, 10 here. So what is the quality? That is the unit. The quantity is the number, which is 10. So this is $10. This is 10 naira. So the $10, the dollar gives the difference. That is the quality of the 10 we are having. So the quality is represented is what we call the unit, while the quantity is what you have as a number. So when we measure anything in physics, we record in terms of 2 parameters. Good. So 2 parameters which they give us the quality and the quantity. So any measurement, any quantity that is measured in physics, you have a number to represent the quantity and a symbol which is unit to represent the quality. So look at practical application of and professional application of measurement. When we talk about measurement, at times some students will look at some topics and say, do I really need it? Let me tell you, like physics is life. There's nothing you will do that you will not talk about physics. So this time around, we are looking at measurement. You will see that almost every area of physics, every areas of life, you make use of the word measurement, or you make use of this aspect of physics. Look at this. If you say, I want to become a medical doctor, what do I need measurement for? No. Even a medical doctor will prescribe dosage of drug for you. Will tell you one in the morning, one in the afternoon, one in the evening. It will measure it. Even a medical doctor also that wants to give injection, we measure the amount of the volume of the dosage he's going to give you. So a medical doctors also make use of it. Engineer, when a civil engineer wants to go to the site and see what is done, he will tell you, measure 2 for every bag of cement, measure 2 wheelbarrow full of sand and the like. So if they will measure, they will quantify it. The architect, of course, they measure. The broadcasters, they consider the time and the days of the program. They measure the length of their program. Everybody makes use of measurement. Even the banker, they quantify their money. So, of course, they measure. The tailors, when they want to take your size of clothes, they take measurement. The artisans, the sports, the cook, the cleaner, every field of life make use of measurement. Now, let's look at other subjects. How does this topic link to other subjects? If you are taking food and nutrition, you know that you will talk about measurement. Because when you are cooking, you will take portions, so you will measure. If you are talking about technical drawing, you are also going to measure. Mathematics, of course. You are talking about numbers, you will measure. Even English language, may I let you know that you measure? I should tell you how. When they ask you to write essay, write 250 words. Are you not counting the words? Of course, you are measuring. There is no field, there is no subject that will not talk about measurement. Interesting? Let's continue. Now look at it. When we measure, there are quantities that we measure. The quantities that we measure, they are divided into 2 segments. We have the fundamental and the derived quantity. When we say fundamental, from the word fundamental, basis, the onset, the beginning, derived, which means that we extracted them from somewhere. Let me give you a hint. Those derived quantities, they are extracted from the fundamental quantities, which means that if the fundamental quantities are not existing, there's no way the derived quantities can exist. So look at it now. We have 2. Yes. So fundamental quantities, what are they? Basically for this class, we are looking at the 7 fundamental quantities. Look at this. We have length. It's a fundamental quantity. Now, let me tell you this. When you hear the word length, some of you will just be wondering length. It's a word that has diverse meaning. When you hear the word length, it also means distance, because length is separation between 2 points. So it also means distance, it means displacement, it means height, it means breadth, it means thickness. Once it's a separation between 2 points, it's what we call length. The next, we talk about time. Time is the interval between 2 events. You measure it. When did that incident happen? And when did the other incident happen? So the interval between 2 events is called time. So it's a fundamental quantity. The other one is mass. Mass is talking about the quantity of matter in an object. It is a fundamental, the basic quantity. More so, temperature. Temperature is telling us how hot an object is or how cold an object is. It is also a fundamental quantity. Electric current. Electric current also is a fundamental quantity. Amount of substance is a fundamental quantity. Lastly, among these 7 fundamental quantities, we have luminous intensity. So, looking at all these quantities now, I told you that once you measure any parameter in physics, you record them in terms of their quality. So, which means that if you have length, there is a quality of length. Let's assume this way. I'm walking from this place to the other end of the room. That is a length. The same way, I can walk from Lagos to Ibadan. That is length. So I need to quantify it. I have quantified it, but what is the quality of that length? That is the unit. So look at it now. Every of these quantity have their quality, which is the unit. So once you measure length, you can record it in meter. But mind you, this is not the only way you can report or you can give the quality of these quantities. But it is what we call the SI unit, the one that is accepted globally. For instance, now, your meter. You can decide to report in centimeter. You can decide to report in millimeter. You can decide to report in decimeter. You can decide to report in kilometer and so on. But the SI unit, the one accepted worldwide that you will use for all problems in physics is what? Meter. Now let me tell you something. Do you know you have been learning physics from primary school? You are surprised. When you were in primary school, they will tell you 10 millimeter make 1, 10 centimeter. You've been learning physics. So that's to tell you that physics is so beautiful. Physics is interesting. So time, you've learned about 60 seconds, make 1 minute, 60 minutes. You've been learning physics from the scratch. So don't let anybody tell you that physics is hard. Physics is not hard. You will get to see it during these lessons. Now, time, the SI unit of time is seconds. Mass is kilogram. Temperature, Kelvin. Also, temperature can be measured in degrees Celsius and in Fahrenheit. But majorly, the SI unit of temperature is Kelvin. Electric current, ampere. Amount of substance is mole. Luminous intensity is candela. So, this unit, most of the time when we are writing it, we don't write the unit, we don't write everything. We use a particular letter. So, for meter, we use M, just like this, as you can see at this side. Let's go to the next part. Now, the derived quantities. The derived quantities are quantities that are obtained by combining two or more fundamental quantity. Don't forget, the fundamental, they are the basis. Then the derived, you merge two or more fundamental quantity, even if it is the same quantity that you are merging together. Once it makes sense, it will produce a derived quantity. I will tell you that. Look at area. Area is a function of combining the same fundamental quantity like your length. And once it's making sense, we have the unit area. We have volume, we have velocity or speed, we have acceleration, pressure, momentum, impulse, energy, power. All of these and many more. Any other quantity you have in physics, aside the 7 I have given you, they are all derived quantities. So I just listed these 10 so that you be aware of what we are doing. So as you go through your study in physics, you come across all other quantities. Those other quantities also, they still stand to be what? Derived quantity. So look at it. For all these quantities, we have the unit, we have the abbreviation. Like area. Area is measured and reported in meter square. So this meter, like I told you that time, the symbol is M. And then square is here. Volume, meter cube. We have meter raised to power 3. Then velocity or speed is measured in meter per second. You can see the abbreviation there. Acceleration, same thing. If you go down to momentum, momentum is measured in kilogram meter per second. And you can see kilogram, kg, meter, m, then per seconds. You have impulse, Newton seconds. So NS. Energy is measured in joules. That is J. Then power is measured in watt. Now, let's look at measurement of length. Like I told you that time, the word length, most students used to mix it up, but don't mix it up. The word length means so many things. Like I said, measurement of length is talking about the separation between 2 points. So look at it now. If you talk about length itself, it means length. If you talk about breadth, in measurement, it also still means length. We are only separating two different lengths. That's why we have length and breadth. Length, breadth also is still a form of length. We also talk about width. When you talk about width, width also is a form of length. Thickness. So we are looking at how thick it is. If you look at this pen now, from this space to this space, tell us how thick it is. So it's a form of length. So the length from up to down, that's thickness. If you're talking about a circular object, so from the center to the circumference, it's called radius. It's a form of distance. It's a form of length. Also height. Height is telling us the distance, the length from the ground to the top. Then diameter and all of that language. Once it's giving us the separation between 2 points, it is a form of length. Let's look at measurement of length. Look at this diagram. It's telling us tools that we use to measure length. We can make use of tape rule. You can make use of meter rule, your ruler. So you can see now I told you that measurement is very important in our day-to-day activity. Let's go. Now, this is also a measuring tool. We have two measuring tools here. This is vernier caliper. This is micrometer, screw gauge. So if you look at this one now, this one can be used to measure distances that are very long. But for objects that are very small, look at the tip of your pen. If you have a pen, the tip of your pen, if you want to measure how thick it is, don't forget that I've mentioned that thickness is a form of length. So if you want to measure how thick your pen is, you make use of micrometer screw gauge. Now, also, if you want to measure the width of your meter rule, look at your meter rule. You want to see from this place to this place how wide it is. You can make use of the vernier caliper. So all of these instruments also, they are used to measure length. Now, let's talk about measurement of mass. When we're talking about mass, mass is a quantity or the amount of matter in a substance. So when we look at the word mass, most of you make mistake by mixing mass and weight. If you measure anything and it is in kg, it is mass. What you call weight must be measured in Newton. Let me tell you something. If you go to the woman selling fish and you want to buy fish and they say how many kg, they will tell you it's weight. Do you know it's not weight? It's mass. Once it is measured in kg, it is mass, not weight. So look at this now. Mass is constant everywhere. Anywhere you go to, your mass remains your mass because it is a quantity of matter that is in you. If you take a stone from here and you go to Jamaica, it is what is still in that stone is still in that stone. It's not missing. So mass, anywhere you take an object to, that mass will still be the same all through. Now, it is measured using beam balance. There's an instrument we use to measure mass. It is called beam balance. I'll show you in the next slide. Now, the SI unit of mass is kilogram. So which means that after measuring mass, you want to report to us the quantity you have actually measured. You want to tell us the quality of that mass, you report in kilogram. But at times, when masses are very small, you can report in gram. You can report in milligram, and so on. So look at this instrument. This is the instrument for measuring mass. This is called chemical or beam balance. Let's look at the next. Weight. When you look at the word weight, what is weight? Weight is a measure of the force of gravity on an object. Once the force of gravity is added on an object, that object has a weight. That is why if you go to space, they said all objects are weightless. Why? Because there is no force of gravity acting on it in space. So weight is a measure of force of gravity on an object. This time around, it is measured in Newton. Yes, weight is measured in Newton. Weight measured in Newton. Now, something comes to your mind. You would have heard that force is measured in Newton. When we're listing different derived quantity, we have force. So, which means we can at times use weight as a form of force. So, let me also buttress that different forms of force. Force can come in the form of force itself. It can come in the form of weight. It can come in the form of thrust. It can come in the form of tension. All of these, there are still different versions of force, and they are all still derived quantity. So, in your objective questions for WAEC or JAM, you can have this question like, which of the following is odd? You can have mass, thrust, force, weight. If you look at all of these, weight is a form of force. Thrust is a form of force. Then force itself is force. But mass is not a force. So you will know the application, the relevance of what I've just said, preparing for your exam. Now, the instrument used for measuring weight is the spring balance. The picture of the spring balance is here. This spring balance is used to measure weight. But look at this last part. Weight varies from place to place, which means that if you are here in Nigeria and you take your weight, you can get to US and your weight will be slightly different. Why? Because of the value of acceleration due to gravity. Remember that weight is equals to mg. Like we said, is a measure of the force of gravity. So because of the value of acceleration due to gravity that changes, so it affects the value of weight. So that is why weight varies from place to place. So this is diagram for spring balance for measuring weight. All right, that's all about measurements. But I'm going to give you 30 seconds to look at what you have in the next slide. In the next slide, you have practice questions. So you have 30 seconds. I'll be back. All right, thank you. How did you find it interesting? Okay, look at the word measurement. What can you say about measurement? Okay, we are quantifying objects. We are measuring objects. We are looking at the quantity of a particular object. That's what we call measurement. We are quantifying the substance. Now, differentiate between fundamental and derived quantity. Like I said the other time, fundamental means the basis, while derived is gotten from combining two or more fundamental quantity. And don't forget, if there's no fundamental quantity, there's no way you can have derived quantity. So which means fundamental is like the foundation, while derived is like the superstructures you have on the foundation. So let's go. Let's look at mass and weight. What can you say about mass? What can you say about weight? Do you have similarity? Do you have differences? Let's look at it together. I told you, look at it. Let's go this way. Come and see here. Mass. Mass is the quantity of matter in a substance. Before I continue, when you are asked to differentiate, I would advise you to use a tabular form. And you make your comparison, you use the same parameters of comparison. Let's say you are using definition. You will define mass here and define weight here. So you are comparing definition. So when you say mass is the amount of matter in a substance, you come to weight and say weight is the measure of the force of gravity on an object. So the two pairs, the first pair must be correct. So that is fine. Then the next one, you can compare the unit. Number one, we have compared the meaning, the definition. Number two, let's compare the weight. Look at it here. Mass is measured in kilogram. That's the SI unit. So you go to weight, you look at it. Weight is measured in Newton. So we're having two differences between mass and weight. Let's go to the next one now. Let's compare the instrument for measurement. Number three, mass is measured using beam balance. But what happened to weight? Weight is measured making use of what? Spring balance. More so, there's a particular statement I made here that we can also use to differentiate between mass and weight. We see that mass is constant everywhere in the world. But how about weight? See for yourself. You see, like I said it here now, weight varies from place to place. So from all this information you have here, you can get at least 4 differences between mass and weight. I'll give you one bonus. Mass is a scalar quantity, while weight is a vector quantity. And to answer the last question, which says that highlight instruments used for measuring length, mass, and weight. We have for length, we have the meter rule, the tape rule, all those ones, the micrometer, screw gauge, like I've mentioned. Then mass, the beam balance or the chemical beam balance, whichever way you call it is fine. Then the weight, we make use of the spring balance for measuring it.
Co-Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Okay, for any comments, observation, or question, contact us on our social media handle that will be displayed. Thank you.